So we're going to start with counting significant figures because in order to work any of the other problems, we need to be able to report our answer to the correct number of significant figures. So a lot of times students ask, how far out do I go? How many decimal places? When do I stop recording numbers? Because your calculator usually gives you a huge long number and not all of those numbers are important. So we use significant figures to figure out which ones are important so that when you go to solve a problem, you know how far out to go. All right, so the rules, and these were presented on the PowerPoint, so this is a shortened version of the rules so that we can apply them to the following problems. So the first one says the leftmost non-zero number is the most significant. Okay, so all that means is you start counting when you get to your first non-zero number. Okay, so this number here, I would start counting at the 1, because that's the first non-zero number. Coming over here, I wouldn't start counting until I get to the 7, because that's my first non-zero number. So that's all Rule 1 is saying. Don't start counting until you get to a non-zero number. The second rule says any zeros between two non-zero numbers count. Okay, so the thing with significant figures is, if it's not a 0, it counts. So 1, 2, 3, 4, 5, 6, 7, 8, 9. They all count no matter what, no matter where they are. Zeros sometimes count and sometimes don't. So these next two rules are saying when they count. So 2 is saying zeros count if they're between two non-zero numbers. So looking at these examples, that would apply to this one down here. We have 4.09. So this 0 is between two non-zero numbers, so it would therefore count. Now the last rule says that zeros can count, 1, if there's a decimal present, and if you've already started counting. So I'm going to go to this example, and we'll work through each of these individually, but I just want to point out the rules as we go. So we have a 0 at the very end of this number. So to figure out if that 0 counts, we apply Rule 3. There's a decimal present, and we started counting at the 2, so that means yes, that 0 counts. So that's what Rule 3 is saying. So what we're going to do is work through each of these and count the significant figures, applying the rules over there to the left. So the first one is pretty straightforward. It's 13.2. So all of these are not zeros. So what does that mean? It means all of them count. Zeros are the only ones that sometimes count and sometimes don't. So I just count them. 1, 2, 3. So I have 3 significant figures. And I usually shorten sig figs by writing just SF. So especially when it comes to labs, because I'll be grading your labs online and I can write on them. If you miss significant figures, I'll write wrong SF. So that's what that'll mean when you get to labs. That's the main thing that people lose points on in labs, is they forget to count the sig figs when they're doing their calculations. So we need to take what we're learning here and still apply it when we go to lab. So the next one, it's a negative. Now I wanted to throw a negative number up here just to show you it doesn't matter. Positive, negative, same rules apply. We still count the sig figs the same way. So in this one, we start counting at the 2 because the leftmost non-zero number counts. The 9 counts because it's also not a 0. The 7 counts because it's also not a 0. So now that we get to a 0, we have to figure out if it counts or if it doesn't. And we just talked about this a minute ago. Rule 3 says it does count. Why? Because there's a decimal point and we started counting at the 2. So that means yes, it counts for a total of 4. So the next one now, we have 530,000. Right, so let's just start counting at our first non-zero number, which is going to be the 5. 5 counts, 3 counts. Okay, now we have 4 zeros, so we need to figure out if they count. Well, let's look at the rules. Does Rule 2 apply? Are those zeros between two non-zero numbers? No, they're not. So far they're not counting. The third rule says zeros count if there's a decimal present. Do we see a decimal anywhere? No, it's a comma. So no decimal point, the zeros aren't between two non-zero numbers, so they do not count. So this number only has two significant figures, just the 5 and the 3. The zeros don't count this time. If we wanted them to count, what we would have to do is add a decimal point at the end. There is no decimal point, so they don't count. All right, last one, or not last one, but last one in this row. 4.09. So we know the 4 counts and we know the 9 counts. So figuring out if this 0 counts. Well, if you look, actually both rules apply, right? Rule 2 says any zeros between two non-zero numbers count. So it for sure counts. But you could also apply rule 3 too. There's a decimal point present and we started counting at the 4. So the 0 counts no matter which rule you apply for a total of 3. This next one's a little tricky because a lot of people approach a number like this and they see the decimal point, so they want to apply rule 3 and they want to say, yeah, those zeros count because there's a decimal point. But you have to remember, it's if there's a decimal present and if you've already started counting. And we said in rule 1 that you can't start counting till you get to your first non-zero number. So we can't start counting till we get to the 7. So that means the zeros before, decimal point or not, they can't count unless I've started counting. So the 7 counts, that's where I start counting. The 5 counts, and now the 0 after those numbers, it will count because there's a decimal point and we started counting at the 7. So this will give us a total of 3 significant figures. Any questions on that one? That's usually the hardest one.
Like when it has a zero, like a decimal, then a 0, and then numbers, and then another 0.
Mm-hmm.
Since you already started counting the 0 after, like say the 0 after the 7.5, that counts each
Yes.
time?
So if I had 5 zeros here, all of them would count because I started counting at the 7. But you can't count any of the zeros before the non-zero number. All right, let's try 670. So we know the 6 and 7 counts, but does this 0 count? So it's not between two non-zero numbers. And is there a decimal point? No. So that means it does not count, just like in this example down here. So there's only 2 significant figures in that one. Now the next example, we have 1,000, but this time notice I have a decimal point at the end. So the reason the decimal point is there is whoever took this measurement or got this data point is saying those zeros matter. Make sure you are counting them. So that decimal point is trying to tell you to count the zeros. So we start counting at the 1. Since that decimal point's there, these zeros do count for a total of 4. So if you ever need a 0 to count in a big number like 670 or 530,000, all you do is add a decimal point at the end, and that will include those as significant. All right, so it's important to know how to count the significant figures because what we're going to do next is we're going to do some calculations with numbers, and the significant figures are going to help us go out the right number of places. So I'm going to erase this section here and just put up the rules for calculating. Just a shortened version like we saw on the PowerPoint. So there are different rules for addition and subtraction than there are for multiplication and division. So for addition and subtraction, we're looking at decimal places only. And we pick the least, or the smallest number. For multiplication and division, here we're looking sig figs as a whole, just like we did over here. Alrighty. And we are still picking the least. All right. So the important important thing when you're approaching a calculation problem is first thing you want to do is look at the order of operations. What are you doing? Are you adding? Are you subtracting? Are you multiplying? Or are you dividing? Because depending upon what order of operation you're using, it has a different set of rules. I'm just going to write a whole bunch and then we'll work on them. One more. Good. So, you'll notice how I wrote them. If it was addition or subtraction, I lined them up by the decimal point. Usually when you get a problem, whether it's in your homework or on the exam, they're not going to line it up for you if it's addition and subtraction. They'll just write it out how I have the multiplication ones written out. So the reason I like to write it out this way is because you'll notice the rules for addition and subtraction say decimal places only. So if I line it up by the decimal place, it makes it easier for me to see and figure out how many decimal places I need to go out. So let's approach the first one. So it's addition, so that's what you want to look for. What order of operation am I applying? And addition says decimal places only. So I'm not counting sig figs as a whole. I'm ignoring that completely and I'm looking at just how many places after the decimal. So in this first number, it is 1, 2, and 3. I'm going to write 3 DP because it's decimal places, not significant figures. The next number goes out 2 decimal places. Now it doesn't matter that this is a 0. Okay, it's still a placeholder, it's still a decimal place. It's the 10th spot, right? So it's a total of 2 decimal places. So next, go ahead and solve. I add that, 3.275. Now if you reported this as your answer, it's incorrect because you haven't considered your significant figures. You need to use what you just did, the decimal places, to figure that out. So which one do you pick? You pick the least, the smallest number. So in this case, what's smaller, 3 or 2? It's going to be 2. That's the easy part, is picking the least, right? So 2, what that means is you want to start at the decimal place and go only 2 out. So 1, 2. Now, before you write down your answer, make sure you're looking at the number next to it. Okay? Because if it's a 5 or higher, you're going to have to round that up to an 8. If it was a 4 or lower, it would stay a 7. So in this case, we are rounding up. The answer is going to be 3.28. So we went out 2 decimal places, and we have a total of 1, 2, 3 significant figures.
So,
in our answer.
when you round,
Yes.
you always pick the least, no matter what? Like the least amount of decimal places?
Yep.
Okay. So say the least was 3 or 4, you would round to the 4th place or the 3rd place?
Yes.
Okay.
So if the least was 3, you would round to the 3rd place. If it was 4, you would go to the 4th place. Exactly. And we'll see, so these all have different number of places, so we'll see that reiterated in those. So the next one's subtraction, but we're applying, it's the same, right? Addition and subtraction are done, we're looking at decimal places only. So just kind of look over here to the right. So in the first number, 27.8, we're just doing 1 decimal place in that case, right? And then in this next number, there's 4. But we picked the least, so once we do our answer, we want to round it so there's only one after the decimal place. Okay, so if I calculate this out, let me calculate this one. That's right. I know I'm going to need a calculator for this one. Do you have a calculator by chance?
I do, and it's super fancy. I had to get it for high school, but it's having to get fixed right now.
Oh, okay. I can grab mine and do that calculation then. Sorry, random aside. So this one, pretty sure I calculated that right. Once you have your answer, you don't want to record all those digits. That's the reason we did this, to figure out how far out to go. And we decided that we need to go out one decimal place. So you're just going one spot after the decimal, and it's a 0. But, just like up here, look to the number next to it. Is that going to stay a 0, or are we going to round it up to a 1? In this
So it
case,
has to be a 1.
it's going to have to be a 1, because that's a 9 next to it, so it's definitely more than 5. So we get 21.1 will be our answer.
Is there a specific calculator?
It just needs an EE button.
Okay.
So this one was $20 at Walmart, but it has the EE button, so that's all that matters. Just wanted to calculate that out so it's ready. So we've done addition, we've done subtraction, which follow decimal places. So I'm going to jump up to this one, and now we're doing multiplication. So since it's multiplication, we're no longer looking at decimal places. We're looking at significant figures as a whole. So what we did a moment ago, we're going to look at the whole number, count the sig figs in each, and pick the least once again. So in this first number, let's count our sig figs. 1, 2, 3. Does that 0 count?
No.
So it's between two non-zero numbers.
Oh, so it does count.
So it does count, yes. And there's a decimal place. So either rule you apply, that 0 is going to count. So we do have a total of 5 sig figs for that one. The next number, 0.03500. So remember, we can't start counting until we get to the first non-zero number. So we start counting at the 3. Then the 5 counts. Do the zeros after the 3 and 5 count.
Yes.
Yes, you don't sound sure, but you're correct. So that decimal point's why. Remember, if there's a decimal point, the zeros will count as long as you already started counting.
Okay.
So these zeros at the end, yes, they're going to count because we started counting at the 3 and there's a decimal point. So the zeros before the 3 don't count just because we haven't started counting yet. So we have 4. 1, 2, 3, 4. Now, just like with decimal places, we're still picking the least. So you're looking at the sig figs, which one's smaller? It's going to be the 4. So that means once I get my answer, I'm going to round it so I have 4 total significant figures. When I did it on my calculator, what my calculator gave me was 0.4307445. Okay, so we don't want to use all those numbers, we just want 4. So you start counting when you hit your first non-zero number and then go 4 out from there. So I'm going to start counting at the 4. So the 4 counts, that's 1. The 3 counts, that's 2. 0 is 3, 7 is 4. So these are going to be my 4 significant figures. Now before you write it out, look at the number next to the last one you chose and decide if you need to round or not.
No.
Not this time, right? It's a 4 or lower, so it's going to stay a 7. So the answer to 4 significant figures is going to be 0.4307. So let's do a multiplication one again, so we can redo this significant figure counting. So we're going to start by counting the significant figures in each number that we're using in the multiplication, figure out which one's the least, and then we'll go to our answer. So in this first one, this is an easy one to count just because they're all not zero. It's not zero, they matter. So we have 2 sig figs in that one. Second one's a little harder. Always is when you got zeros involved. So we know the 2 counts, but do these 2 zeros count? It's kind of like up here. Remember, if there's a decimal present, then yes, they count.
Since we already started counting.
Yep, we started counting at the 2, and since there's a decimal, the zeros after we start counting matter. So it's a total of 3. Okay, so we want to pick the smallest, so what's smaller, 2 or 3? It's going to be 2. So once we have our answer, we're going to make sure we're rounding to 2 significant figures. So when I multiply this out, it should be 184. Now this one's a hard one to round, is why I wanted to do this example. Because we just said 2 significant figures, right? You always start counting left to right, so that means you're going to start at the 1. So that means the 1 and the 8. Now I'm at 2, that's it. Okay, and a lot of people do that, and they go, oh, okay, the answer's going to be 18. No, it's not, because I had 180. I can't go from 180 down to 18. That's not the same order of magnitude. I need to be in the hundreds somewhere. So what you need to do in this case is where that 4 is, you need to put a placeholder here, a number that's not going to be significant. So what's the only number we could use that won't count? A 0, exactly. So instead of a 4, we're going to change that 4 to a 0, because now we still just have 2 significant figures, because this 0 is not going to count unless I have a decimal point. So I'm still in the hundreds. I didn't change my order of magnitude, but I still kept just 2 significant figures. So this will be the hardest type of rounding problem that you'll see. Come on in, you're here for chemistry?
Yes.
Yeah, come in. So we already got started with some problems, but whatever ones you missed, there'll be a video posted for that. And then if you need a lab manual, I'll get with you after class to get that to you.
Okay, I'll talk to them.
Okay, no worries. All right, so we're going to try this last one here. We're adding again. So we're kind of skipping around. So when we're adding, we look at the rules for addition and subtraction. So here we're going to count the decimal places only. All right, and this first number here, 5, doesn't have a decimal point even. It doesn't. So if we're counting the decimal places, it would be 0. DP for decimal places. The next number, it does have a decimal, so we're counting just after the decimal, and in this case it's 2 places after the decimal. So we're still picking the least, and so what number is smaller, 0 or 2? In this case it's going to be 0. So all that means is once we calculate this out, we don't want anything after the decimal. We want a whole number, is all that's saying. So I'm going to add this like normal, see what I would get in my calculator, or if I do it on paper. And I get 9.81. So we just said we don't want anything after the decimal, so that means just the 9 is what we're keeping. But you have to make sure to always look at the number next to what you're keeping and see if you need to round up or not. So if it's 5 or higher, that's going to become a 10. If it's 4 or lower, it's going to stay a 9. So in this case, it's an 8, so it's going to round up to 10. So the answer for this one is just going to be 10. No decimal place at all. Questions so far? Okay, yeah, no worries. So what we're going to do now is look at scientific notation. So leave that stuff up for a minute. I'm going to quickly write the rules for scientific notation.
Did I need those, what was in that corner?
It's all on the PowerPoints as well. So on the PowerPoints, I explain all the concepts that we're using here. So what's important mainly is the problems themselves. So you won't need that information for the next problems we do. I'm going to write up a new set of rules for what we're looking at next. So next is scientific notation. And when we're doing that, I'm just going to write the rules that we're going to be applying in order to represent normal numbers in scientific notation. So the first rule is going to be you want one significant figure, so sig fig, to the left of the decimal. Exponent. So everything we did before this, I've been recording, so you'll have access to that video, and you can see like the step-by-step how I went through. All right. So normal. Okay, so there's a lot of right, but,
What is it, number 3, what does that be? What did you?
oh, check, this is a check mark.
Oh, okay.
Sorry, check your significant figures. So it's just kind of the last step to make sure that you're reporting the right amount of numbers. All right, so with scientific notation, what that is it's where we're rising to a power. Okay, so 10 to the third, 10 to the negative eighth, so on and so forth. So what this x represents is an exponent. So when you see the word exponent, that's what I'm referring to, is what power are we raising it to. Okay, so we're going to take numbers in normal notation, so this is how we normally write them on a daily basis, right? We'll write decimal places, or if it's a large number, we'll write commas and zeros. So what scientific notation is going to do is it's going to shorten that for us. So that, for instance, if we were trying to write 500 billion, okay, we wouldn't have to keep track of the many, many zeros that come after that. We would just write it as an exponent instead. It's going to save us some space and some time. So how do we do this? Okay, so these rules we're going to apply to each of those normal notation numbers so that we can represent them in scientific notation. So the first rule is saying we want one significant figure to the left of the decimal. So when I say significant figure, I mean a non-zero number. So I want just one non-zero number to the left of the decimal. So I'm going to do that for this first one. So the decimal point now is between two zeros. When I represent it in scientific notation, I'm going to put a new decimal point in it. And where am I going to put that? I'm going to put it between the 2 and the 4. How do I know that? Because of that first rule. That first rule says, I want the decimal so that there's only one non-zero number to the left. And that's the only spot I can put it, so there's just one non-zero number to
So
the
you
left.
count it this way?
We're going to be moving it to the right to get it there, yes. So that means I'm going to start writing it that my new scientific notation is going to be 2.4. times 10 to the, now this is the part we need to figure out using the next rule. This is the exponent part. So what is my exponent going to be? Well, it's going to be the number of times that I'm going to have to move the original decimal point to get it to where the new decimal point is. Okay, so let's count. 1, 2, 3. 3, exactly. So it's going to be a 3. Now you're not done yet, because exponents can be positive and they can be negative. So you need to look at your original number and figure that out. So there's two ways to figure it out. One is, if the original number was greater than 1, it's going to be a positive exponent. If your original number was less than 1, it'll be a negative exponent. So in this case, the number was 0.0024, so that was less than 1, right? And we just said less than 1, it's going to be negative exponent. The other way people like to remember it, if I move my decimal point to the right, negative exponent. If I move my decimal point to the left, positive. Both rules work.
So the left will always be negative,
Negative.
right is positive.
No, I think you got that wrong. So the right is negative,
And right is
left is positive. I remember the greater than 1, less than 1 way, but not everyone likes that way. So whatever one sticks in your head, use that one because it'll work. And we'll do several more so you'll see the directions and be able to apply. Now notice I had that last rule there, check sig figs. Okay, so you're counting which numbers matter and making sure it remained the same. So in this original number, it was just the 2 and the 4, those two non-zero numbers. So there was 2 significant figures over here. And when we're counting sig figs for scientific notation, we're looking just before that multiplication sign. Okay, so it's still just 2. So I'm just checking there. On this next one, what I'm going to do is I'm going to count my significant figures first. Because sometimes, once you start moving the decimal points around, counting sig figs can be confusing. So it's best to do it just right away, and then that way at the end you can just quickly check. So we're going back to what we learned at the beginning of class. Let's count the significant figures in this number. So when we're counting significant figures, you don't start counting till you hit your first non-zero number. So we are not going to start counting till we get to the 1. So that's my first significant figure.
Oh, okay.
The 8 counts because it's not a 0. If it's not a 0, it matters. But does this 0 count at the end? That's the tricky ones, are the zeros. So to figure out if zeros count, the rules say, yes, zeros count if it's between 2 non-zero numbers, and this 0 is not between 2 non-zero numbers. The other way a 0 can count is if there's a decimal point. And in this case, yes, there's a decimal. So this 0, yes, it does count because there's a decimal point there, and we started counting at the 1. So for this one, we have a total of 3 significant figures. The 1, the 8, and that last 0. So once we get it in scientific notation, we'll just double check and make sure we kept all 3. All right, now let's represent it in scientific notation. So where are we going to want our decimal point in this number? Between what two numbers?
The 1 and the 8.
The 1 and the 8. Because the first rule says we want just one non-zero number to the left, and that's the only spot it'll work. So when I go to write it over here, I'm going to have 1.8. And notice, since I have the 0 over here, it says it's significant, I want to make sure that I'm keeping the 0. That's the reason we counted in the first place, so that I still have 1, 2, 3 significant figures. Now for the exponent part, we're using rule 2. We're going to count from the original decimal point in black here, how many times we have to move it to get it to the new spot. And it's just 2 this time, right? And notice I moved to the right 2 times. And if you move to the right, it's going to be negative. The other way is this original number, it was less than 1, right? It was a decimal point, it was 0.0 something. Less than 1, negative exponent. So both of the numbers we've done so far have been less than 1, so we've seen only negative exponents so far. Notice this next number, much greater than 1, right? It's 600,000. So we would expect a positive exponent for this one, right? But let's go ahead and work through it methodically with those rules. So where are we going to want our new decimal point between what two numbers? We're going to be going to the left this
7
time.
and 3? No?
Not the 7 and 3, because then we'll have 2 numbers to the left of the decimal, and we only want 1. So it's going to go between the 6 and 7 this time. And that's a common mistake. Some people put 2. Some people sometimes put it way over here so that there's none. Okay, so that's a tricky part of it. You need to make sure there's just 1 to the left. So this is where we want our new decimal point. So 0.6.73. Do you think I'm going to include those zeros? So let's look at the number before I put a decimal point in there. Okay, let's count our sig figs. We know the 6 and 7 and 3 count because they're not zeros. This time, do those zeros count? So up here, this 0 counted because there's a decimal point. Is there a decimal point down here? It's a comma, so it's not a decimal. So these zeros do not count. They can only count if there was a decimal, like up here. So that means there's just 3 significant figures here. So we're not going to include the zeros in our scientific notation formation. That's what's nice about scientific notation is we can lop off those trailing zeros that don't matter. We don't have to write them again. So let me put back in that decimal place so that we can figure out our exponent. So now we said that we need to figure out how many times to move the decimal to get it there. Well, we just said this number doesn't have a decimal. So if you approach a number and there is no decimal, you're just going to start at the end of the number. Okay, so you're making a decimal. So I'm going to start at the end and I'm going to count how many times I have to move it to get it between the 6 and the 7. So 1, 2, 3, 4, 5. And remember this time I moved to the left. So I moved 5 times to the left. So it's going to be a positive exponent. The number was greater than 1, positive exponent. I also kept my sig figs. I still just have the 3. Questions so far? So let's try this next one, and I'm going to count sig figs first. I forgot about it on that one before I got moving stuff around. So to count my significant figures, I start at the first non-zero number. So the 1 and the 5 count. So far I have 2. Now this time there's a decimal point present. So what is that decimal point telling us about those zeros? Do they count? They count. That's why it's there. It's saying, hey, don't forget about those zeros. So I have 4. So that means when you represent it over here, you want to keep those zeros in the scientific notation form. Okay, so if I put it in scientific notation, where do I want that decimal to be between what two numbers? The 1 and the 5, because I want just 1 to the left. So I write it over here, it's going to be 1 and 0.5, and I just said keep those zeros, so don't forget them. That way I still have 4 sig figs. To figure out the exponent, how many times am I moving that decimal to get it between the 1 and the 5? 3 times, yeah. Is it going to be positive or negative? Positive, right? I moved to the left. The original number was greater than 1, so we keep it positive.
I'm having problems on first though, trying to figure out how do you figure out where the decimal goes.
So you're going to put it so there's just one non-zero number to the left. So if I'm looking at a number, let me just erase
And
this.
so with any problem, it's always, any number gonna go to the left.
Right, so let's, 0.00. So where should my decimal point go in that number?
3?
If I put it between.
Oh, no.
Okay.
Wait to the left.
I'm going to the right, but when do I want to stop? Do I want to stop here?
Between the 3 and 5.
Between the 3 and the 5, because there's always just one non-zero number to the left. It doesn't matter if it's a 1, if it's a 3, if it's a 6. You just want to make sure there's not a 0.
Okay.
And you don't want to go further than that, because if I go here, there's going to be two numbers
Okay.
before. So you always want just one.
Even with the commas, you always need one.
Always with, even with the commas, you always just want one. I can't leave this unfinished, so I got to write over here what the answer is. So 3.59 times 10 to the, how many times did we move it? 1, 2, 3. And we moved it to the right, so is it going to be positive or negative? Negative, yes. The original number was less than 1. So what we're going to do now is, this is like the introduction. So we're going to do more advanced problems using all this stuff we just learned. So we're going to continue with it. And I don't mean advanced, I mean we're just going to combine everything we learned. So before we do that, let's go in the reverse. So we just took normal notation numbers, right? And we represented the scientific version. So now I'm going to write scientific notation numbers, and we're going to go backwards and write what they look like in normal. So I'm going to get a few up here. We got 80 times 10 to the negative 7. 2 times 10 to the 5th. 9,000. Third, last but not least, 3.0 times 2 to the 0. Okay. So we know those are scientific notation because of the second half, right? Times 10 to the something. And notice all of these have just one non-zero number to the left of the decimal. So they're incorrect scientific notation. So we're going to take what we know about the exponent to figure out what direction to go and how many times to move that decimal point. Okay? So this first one, the exponent tells me how many times. I know I'm going to be taking this decimal point between the 7 and the 8, and I'm going to move it 2 times. How do I know what direction? The charge on that exponent. So if the charge is negative, right, negative means the original number is less than 1. So that negative says, I'm going to want to move it to make the number smaller. So the only way I can make this number smaller is by moving that decimal point to the left. How many times? 2. So I'm going to start at the decimal. I know I need to move to the left because of that negative sign. I need to make that number smaller. How many times? We just said 2. So I'm going to go 1, 2. So my new decimal point is here now. What do you think goes in that empty space?
0.
A 0, yes, exactly. So my normal notation number,
7.
8, and I'm keeping that last 0.
Hold on. Where that second 0 come from now?
What's that 0? This
Front.
one? Oh, that's just a placeholder.
Okay.
So if you don't include that, that's fine.
Okay.
I just use it so that people can see my decimal better. Questions on that one? All right, so I kind of skipped a step on that one because I didn't count my sig figs first, so let's do that for the next 3. Remember, sig figs in scientific notation are just the numbers before the multiplication sign. So in the second one, how many significant figures are in 5.2? They're both non-zero numbers, so they both count. So the 5 counts and the 2 counts for a total of 2, yes. So that means, once I represented the normal notation, I should only have 2 significant figures as well. Okay, so let's start moving the decimal. So I'm going to move this decimal that's between the 5 and the 2. The exponent tells me that I'm going to move that decimal 5 times. This time, the exponent's positive. What that means, positive exponent means the number is going to be greater than 1. So I'm going to move it to the right this time because I want this number to get bigger. That's what positive means, bigger. So how many times? 5. So 1 time it's on the other side of the 2. And we have 2, 3, 4, 5. Okay? So just like up here where zeros go in the empty spaces, we're going to put zeros in these 4 empty spaces. So that means I'm going to have a 5, a 2, and then 1, 2, 3, 4 zeros after it. I'm going to write that over here so it's a little clearer. So I have a 5 and a 2, and we just said 4 zeros, right? 1, 2, 3, 4. Put a comma in there to help see exactly what the number should be. Now, this decimal that I have at the end, I'm not going to keep it and put it here. Why do you think I don't want a decimal? What happens if I put a decimal there? If I put a decimal there, what I'm saying is these matter. Okay? But I don't want those zeros to matter because my scientific notation form had 2 significant figures, and I want to keep it so just the 5 and the 2 matter. I don't want those zeros to count. Okay, so even though I have a decimal point here, that doesn't mean I carry it over. It's just to show me how many zeros should go there. Any questions on that one? All right, so if we try another one, let's start by counting significant figures, just because once I move the decimal point, I lose how many were originally in the number. So looking at 1.9000. So I know the 1 and the 9 count. Non-zero numbers are the easy. It's the zeros that get tricky. So do these zeros count? No. Okay, why? So the rules, and we covered this at the beginning of class, so the rules for zeros is that if you have a decimal point and you've started counting, and I did start counting, I started counting at the 1. If you have a decimal point, that's saying that the zeros do matter. Okay, so if there was no decimal point, the zeros wouldn't matter. Like here.
It's a comma.
Because it's a comma, the zeros don't matter. But here, it's a decimal point, so the zeros do. Okay? So since they matter, we have to count all of them. So 1, 2, 3, 4, 5. So we have a total of 5 significant figures here. So what all that means is that when I write it in normal notation, I want to make sure to include those zeros in my normal notation version. Okay, so what is normal notation going to look like? Well, I'm going to start at the decimal, and I'm going to move it 3 times. That's what the exponent's telling me. It's a positive number. So do I want this number to get bigger or do I want it to get smaller? Positive means greater than 1. So it means I want it bigger. Yep, to the right. So to the right 3 times we said. So 1, 2, 3. So my new decimal point now is going to go between these 2 zeros at the end. So my number is going to be 1900, and then the decimal point, and then another 0. So since we said those zeros matter, we need to keep them all here. So it's 1900.0. And we still have 1, 2, 3, 4, 5. 5 sig figs, so they still match. Since there's a decimal point, those zeros count. Make sense? Kind of. It will eventually.
It's so easy, but it's something that's making it hard.
not clicking
hard,
yet.
but yeah, not
And a lot
clicking.
of times it's just practice. Keep going and going and going. We're gonna do a lot more problems like this. This is just the first few, so. You're getting confused and then I throw in a trick one at the end. Sorry. So, but it might help you understand it better actually. So in this one, we have 3.0. So let's count our sig figs first, one step at a time. The 3 counts. There's a decimal point, so does that 0 count? Yes, decimal point says zeros do count. So we have 2. 1, 2. Okay. Well now, we look to the exponent to figure out how many times to move that decimal. What's the exponent?
0, so you know.
So you don't move it. So the answer,
3.0.
3.0. Yep. You look towards the exponent to figure out how many times you move it. And it's a 0, so you don't move it. If it's 3, you move it 3 times. If it's -2, you move it 2 times in the other
So
direction.
even if it was the one above 1.9000, that 0, if the 3 was a 0,
Yep,
it would have just kept the
it
same.
would have stayed the same number. Yes, exactly. Any questions? Okay, so let's do a couple more problems. I have let's do rounding and scientific notation. Let's combine some things. Can I erase this? All right, so what we're going to do here, and I try to do problems that are similar to what you're going to see in your homework. So that's the reason I'm wording this one this way. So we're going to round to 3 significant figures so that we get practice with rounding and significant figures. And we're going to express in scientific notation. Long sentence there. So I'm just going to write some numbers and we're going to work through them. A ton of examples, but we'll start with those ones. All right, so we're going to take it one step at a time. We're going to start by rounding to 3 significant figures. Okay, so what that means is we need to count out 3 significant figures, look at the number next to it, round if necessary. So in this first one, remember for significant figures, we start counting when we hit our first non-zero number. So I'm not going to count at this 0 because it's a 0. So I can't start counting until I get to the 7. So the 7 is going to be my first significant figure. 5 will be my second significant figure. And then the 2 is going to be my third significant figure. So this first one already has 3. Okay, so my first step, getting 3 significant figures, is already done for me in that one.
And the only reason we didn't count the zeros is because it's a decimal.
So we didn't count the zeros because we can't start counting till we get to our first non-zero number. Yes,
Actually.
and 7 was my first. So if there were zeros after this, they would count because of the decimal and we started counting.
Okay.
But since we didn't start counting yet, the zeros before don't matter.
Like you repeated to it, please.
That's the hardest rule is
Okay.
ones like this, is because there's a decimal point, so your mind says, those zeros count. You can't count them unless you've already hit your first non-zero number. So it's only zeros after the 7 that would count. So right now there's 3. And so we're going to express this in scientific notation, just like we did before. Okay, so the rules are still up. So where do we want our decimal point in scientific notation? Between what 2 numbers?
0 and 7. The first whole number.
The first whole number.
So that would be after the 7.
After the 7, yes, between the 7 and the 5. Okay, so in scientific notation, it's going to be 7.52. And should probably use a different marker because I was gonna use a C. So my exponent, how do we figure that out?
3. Start with a decimal. 1, 2, 3.
Yep, it's gonna be a 3. Is it gonna be positive or negative? It's gonna be negative, because we moved, you can look at it one way, we moved to the right, or the original number was less than 1. And that's this rule here. So if it's less than 1, it's a negative exponent. So 7.52 times 10 to the negative third. We have 3 sig figs, and it's in scientific notation. So we're combining pretty much everything we learned. Okay, so let's try again. Let's start with the 3 significant figure portion. So, start counting at your first non-zero number, so we're counting at the 6. That's where we're starting, so that's 1. That's 2, that's 3. Okay, so 1, 2, 3, so we stop there. Make sure, this is where the rounding comes into play. Once you stop at your third figure, look at the number next to it and figure out if you need to round or not to avoid. In this case we do, because a 5 or higher means that that 2 is going to go up to a 3. If that was a 4 or lower, it would stay a 2. So we have 6, 0, 3. Okay, so this is the rounding portion to 3 sig figs. So that's just the first step. Once you have this number, then you want to express it in scientific notation. So, to express that in scientific notation, where are we going to have our new decimal point? Between what two numbers?
The 6 and the 0.
The 6 and the 0, because remember we want just 1 to the left. So I'm going to have 6.03 and then times 10 to the, and the original number, right, there's no decimal point here, so we start at the end. So if I start at the end, I'm going to have to move it twice to get it between the 6 and the 3. And it's positive, yes. It's positive because, well, 1, we moved to the left. Or the original number was greater than 1. Both of those work. Yes, 107.4 is the next one we're going to do. So very similar to the one above. We're going to count out 3 significant figures and then round if necessary. So it's actually very similar to this one, right?
Because 4 is less than 5.
Yep, in this case, we stop at the 7, look to the number next to it, it's going to remain a 7, exactly. If it's 4 or less, you don't round up. So 107. And then now we're going to take 107 and put it in, or express it in scientific notation. So where is my decimal point going to go in scientific notation?
Between the 1 and 0.
Exactly, between the 1 and the 0. So we have 1.07 times 10 to the, so how many times do we have to move the decimal? What's our exponent going to be? We start at the end of the number, 1, 2 times to get it there. And we moved to the left. The number was greater than 1, so it stays positive. We have a few more we're going to try. Doing the same thing. Really big one.
So with this in chemistry, this is used for like what?
All of the problems that we're going to be doing. So sometimes we'll get into word problems. We're going to be talking about Avogadro's number, which is an exponent number. It's 6.022 times 10 to the 23rd, so it's like a huge number. And we'll be using that in calculations. So it's good for us to get used to the scientific notation and the rounding when in scientific notation for when we get into chapters 2 and 3.
And what I'm saying is this like, chemistry altogether is dealing with medicine and, like, what is it?
For the health-related fields?
Yes.
So doing conversions, this is leading up to doing conversions, which is what we're doing next week.
Okay.
So we're just playing with scientific notation and significant figures so that when we do conversions, it's
Okay.
second nature to us. Right. Let's do a hard one. That last one's gonna be fun. Okay, so let's start with the top one here. This top one, first thing we want to do is round to 3 significant figures. Okay? So start counting at the 6 and go. 1, 2, 3. So we're stopping at the 7, right? Look to the number next to it. Is that 7 going to stay a 7?
No, let's say.
No, it's going to go to an 8. Okay, so we have 6, 0, 8. But remember, we can't go from 607,000 to 608. We need to put placeholders for these 3 numbers, but we need them not to be counted towards significant figures. So what's the only number we have that sometimes doesn't count? 0. So what we're going to do, instead of this 8, 9, and 2, is we're going to put 3 zeros after that. So it's going to become 608,000. Because this way, since there's no decimal point, those zeros don't count. So we still have 3, just like it's telling us. So once we have that number, we're going to take this number and put it in scientific notation. So scientific notation, where do we want our decimal point between what 2 numbers?
Well, so.
6 and 0.
6 and 0. So you still want just 1 to the left. So it's going to be between the 6 and the 0 here. So 6.08. Do I want to include those zeros? Now I have a decimal point. So if I include these 3 zeros, that means they're going to count. We just said we don't want them to count. So I'm going to stop at the 6.08, so I still have 3 significant figures. Right? So what's my exponent going to be? Start at the end of the number, since there's no decimal point. We're going to start at the end. So what is that? 1, 2, 3, 4, 5. Is it going to stay positive? Yes, the number was much greater than 1. So it stays a positive exponent. All right, we got another decimal point one. So let's start just by going to 3 sig figs and rounding. So where do I start counting? What number? The 1. See, this 0 is not going to count because I can't start counting until I get to my first non-zero number. So I start counting at the 1. The 0 is going to be my second significant figure. The 5 is going to be my third. So I stop at the 5, look to the number next to it. Is that going to stay a 5 or go up? Go up. 106, exactly. Okay, so to represent that in scientific notation, I need to move that decimal point. And I only got to move it once, actually, because I want it between the 1 and the 0. 1.06 times 10 to the, we just said, you only got to move it once to get it there. This time, though, is it going to be positive or negative exponent? Negative, yes. The number was less than 1, so it's going to be a negative exponent. All right, so this is the tricky one here. So let's do 3 significant figures. They're all 9s, right? This first 0 is not going to count, so I can't start counting until I get to my first non-zero number. So we get 1, 2, 3. Look at the number next to it. Does that stay a 9?
Yes. No.
No, because it's 5 or higher, right? So this is going to have to move to a 10. If this moves to a 10, what do you think is going to happen to that? It's going to go to a 10. This goes to a 10, what is that one going to do? Go to a 10. So this 0 is eventually going to be a 1. Yes. So that's why this one's hard, because we round up all the way till we get over here, so we're going to have 1 point, and remember we want 3 significant figures. So how many zeros do you think are going to come after this 1? So if I put 2 zeros, let's see, the 1 counts. Since there's a decimal, those 2 zeros count. So how many total do I have? 1, 2, 3. So I have 3 sig figs right here. Start counting at the 1. Decimal says any zeros after are going to count. So this is 3 significant figures.
Okay, let's see. Where do we get the 2 zeros from?
Because these all turn to 10s, remember? So they're going to be zeros now. So if I were to write this number up after rounding it, it would be 1.000. But that's 4 significant figures. It says you only want 3, so I can't include that last 0. Because I want 3 in my final answer. So for scientific notation, where do I want my new decimal point? Where it is. There's one non-zero number to the left, right? So what's my exponent going to be? This was the trick question from last time. 0. Exactly. How much time we got left? 5 minutes. Okay, I'm going to do one more problem. And then we'll call it a day. This one's going to include the multiplication we talked about as well. So when I did some problems before, I was only using 2 problems in my calculations, 2 numbers in my calculations, sorry. This time I'm going to use 3. Okay? So what we're going to do with this problem, and this is going to help us with when we get to conversion, because we'll have several different numbers involved, is I want to solve this and then figure out what my significant figure should be in my answer. Okay? So I'm going to start by just solving it. I'm going to put it in my calculator, I'm going to see what the answer is, and then I'll worry about significant figures. So 21.5 times 0.98. I'm going to divide that by 1.11. So what my calculator spits out is 18.98198. Okay, a lot of numbers. I don't know all those numbers. You don't want to write down all those numbers. So what you need to figure out is how many numbers are important. How many numbers are significant. So we're going to go to our original problem and count the significant figures for each number involved. Okay? Because notice, we're multiplying and we're dividing. And the rules for multiplying and dividing is you count the significant figures in every number involved and you pick the smallest. Okay, so let's just look at the numbers individually. This first number, 21.5. How many significant figures are in that number? 3. They're all not 0, so they all matter. So there's 3 significant figures in that one. Okay. How about 0.98? How many? 2. This 0 doesn't count, right? We can't start counting until we get to the first non-zero number. So it's just 2. And then down here, 3 again. So we look and pick the smallest. So what number is smaller out of all these? 2, right? 2 significant figures. 2 is smaller than 3. So what that means is, when I get over here to my giant number, I only want 2 significant figures in my answer. Always start from the left and go towards the right. So I'm going to start at the 1. So that's 1 significant figure, 2. Look to the number next to it. It's going to go up. So when you report your answer for that huge long problem, you're just